So we're going to look at availability zones. We're going to talk briefly about what they are, and if you come to the realization that you don't need an availability zone on a particular resource, I'm going to show you specifically for virtual machines how you can actually get rid of that setting. It's not quite as easy in Azure as just flicking a switch as it is with most things through the portal. But the thing to be aware of here is that as of next July 2023, Microsoft are going to start charging for data that comes in and out of an availability zone or crosses an availability zone. It's actually slightly more convoluted the way they lay out how they meter that. But needless to say, it's an additional charge. And one thing I've kind of witnessed is that there's a lot of virtual machine resources that are being created with availability zones switched on. I think sometimes this is by design through the architecture. I think many times it may just be a slight confusion with availability sets. Availability sets are a way that we can ask Azure to distribute our virtual machine. So if one of their server racks goes down in a data center for maintenance or through just general fault, then we can make sure our virtual machine will keep running because it will be distributed across other, they're called fault domains in that case. So I have a virtual machine here. It's set to availability zone 1. And before I do anything about that, I just want to talk about availability zones. So the Azure availability zone, if we work with this graphic here, within one Azure region, there is typically at least 3 availability zones. And these availability zones are kind of virtual placeholders for data centers. So the fact that I've selected my virtual machine to be in availability zone 1 in central US, it means it is tied to one of their data centers. Now that's not necessarily static. What it's given me there is the ability to say that whichever data center this virtual machine is in, if I start another virtual machine and that's in availability zone 2, I can guarantee that those 2 virtual machines will not be in the same data center. One will be one data center and one will be in the other. Conversely, I guess similar thinking as proximity groups, although not quite the same, not quite as refined. If I had multiple virtual machines with availability zone 1, I can guarantee that they will all be provisioned in the same data center. Now, why does Microsoft have this? Well, the primary reason is to allow us as architects to be able to create more highly resilient available services without needing to cross regions. So what we mean by that is an individual data center is susceptible to natural disasters, floods, storms, power outages for an entire grid. So that is a risk to an individual data center. So what we may want to do is if we have an application where we know we have redundant virtual machines, the same application running on 2 separate machines, we may want to put a load balancer in front of that to distribute the traffic between those 2 virtual machines. Now, sometimes we'll do that for performance. If we can share that load, then we can get more performance. But we also want to use it for a level of availability as well. So if one of those virtual machines was to drop for some reason, it was to have a failure, whether that's within the software layer itself, or whether that's the actual hardware backed behind it, if that goes down, the load balancer will sense that that is no longer available and it will direct all traffic to the other virtual machine. So that works great in most use cases apart from the physical aspect of it in Azure. So if our software fails on one but not the other, that's no problem. But if there's a physical failure, if one of these data centers is taken down even momentarily because of some kind of natural disaster or some kind of problem in that data center, where the whole data center is taken out. So, availability sets we normally spread across multiple racks within one data center. Well, we're talking about the whole data center going offline. So it doesn't matter that it's on different racks because the whole data center is gone. What we want to make sure we do is when we provision our 2 virtual machines, we don't want them in the same data center, because that would completely negate the whole point of having a load balancer, sharing traffic and having some fault tolerance between those two virtual machines. So by using availability zones, we set one virtual machine as availability zone 1 and another as availability zone 2. We can guarantee that they are in different data centers. So we can guarantee that extra level of high availability if one of those data centers goes offline, because we know the other virtual machine is in another. And if we wanted to be really paranoid, I'm not sure if it gives us any more 9s, but we could have 3 virtual machines, 1 in each availability zone. Microsoft and the documentation talk about, there's a certain minimum level of distance between their data centers to make sure they are, protected from things like earthquakes, floods, and fires. So that's the purpose of availability zone. If you go in to create a virtual machine and you select an availability zone, you are not automatically getting any more availability out of that virtual machine. You need to provision another virtual machine in another availability zone, and you need to manage the load balancing to make sure your application is distributed over those 2 virtual machines. That's the only time when you actually see that increase in availability. So as of, it was going to be July this year, a couple of weeks ago, Microsoft were going to start charging for traffic that crosses the boundary of these availability zones. So data that was written out of availability zone 1 into availability zone 2 would be charged, which makes sense. It's been a free service for a while, but there is a bit of an overhead to this, so Microsoft are rightfully charging for that. The problem you have is if you've provisioned a lot of virtual machines where you've used availability zones incorrectly, you didn't really mean to, and you've got traffic going from this virtual machine to any other virtual machine, even ones that are not within an availability zone, that traffic then may flow to that virtual machine in the same data center, or it might not, it might be in a different data center. The fact of the matter is Microsoft are going to charge you for the data traveling across that boundary, just by the sheer fact that you've guaranteed one of your virtual machines is going to sit in a particular, or stickiness to a particular data center. So in many cases, we find virtual machines where we want to switch this off. You can see here we've got our availability zone. If we go to availability and scaling, I don't have any of the other availability sets or fault domains set up. So, I have no opportunity there to change them, but you can see it also doesn't show you availability zones in here. So the question is, how do we get rid of that availability zone setting? Good news and bad news. The bad news is we need to destroy the virtual machine and recreate it in Azure. The good news is that doesn't mean you have to reconfigure everything. It doesn't mean you have to rebuild the image or that you're going to lose any data. There's a couple of caveats I'll cover in this, but I'm going to go through a simple example of how we can do that. So what we're going to do, I'll just preview this and then we'll come back to it, is we are going to delete this virtual machine. But you can see I'm given some options here for associated resources. I've got the operating system disk, an additional data disk I attached, a network interface, which will have any security rules applied to it. It's also connected to a VNet, and I've got a public IP address, which might have some DNS name mapping to it. So I can choose not to delete them when I delete this virtual machine. So that's the main thing. We can basically just delete the metadata that represents this virtual machine being provisioned, and we can retain everything else that is actually critical to us. The OS disk with all the configuration upon it, the data disk, the network interface, and the public facing IP address. So before we do that, first thing we're going to do is we're going to actually export what this virtual machine looks like in an ARM template. So we go to the export template view. I'm quite simply just going to do download here. We will look into this in a moment. I'm going to go back here to my virtual machine. I'm going to say, well, let me open up my resource group first so we can see the other items. You can see there's my virtual machine, the public IP, a network security group, network interface. There's one disk. I thought I had another disk here. Let me refresh that. There's my data disk. That's everything that constitutes this virtual machine. So we'll go into this virtual machine. I'm going to say delete. We are going to make sure the only thing we delete is the virtual machine, but we retain everything else. And I understand, and I'm going to hit delete. So it shouldn't take too long for this to go. I just recently provisioned it. If we go back to the resource group, I'm going to hit refresh here in a moment or two. While we're waiting for that, let's just go and look at the ARM template I downloaded. So it comes in a zip file. I'm going to extract them all here. And then I'm going to just have a look at these I'm just going to use VS Code, but you can use Notepad if you really wanted to. Okay, so there's two files I'm given. The first one is a template. This is the ARM description for this entire virtual machine. And then the other one is parameters, which is if I want to actually set some parameters. So normally you can use ARM templates to download a resource as a template, and then you can change some parameters for deploying net new different resources based on the same kind of model. So we're not really interested in this. If we actually look back in the template, it shows us where we define the parameters like the virtual machine name, and it's got some default values in, and those default values come from my original resource. So some important things here. The OS disk has a default value, which points to the managed disk that was for the OS. Then I've got my data disk, and then I've got my network interface. Okay. Now, let's go back and make sure that resource is now deleted. Okay, refresh. So we've got our IP, we've got our network security group, we've got our disks, we've got our regular network interface. So my virtual machine is gone, but the real artifacts that make it up are still there. So there's a couple of modifications we actually want to make to this file. You know, if we were to run this as is, we're basically saying recreate the virtual machine, but there are a few quirks within this. So the first thing we want to do, if we go to the OS disk, you can see we've got managed disk, and it's got an ID in there, and this ID points to a parameter. And this parameter at the top here is the reference. The default value, if we don't override it, is going to point to my original disk, this test OS disk 1, which is this one here. So you might think, well, that's great. Well, these ARM templates are net new. So it's kind of saying, okay, we're going to create it from an image. We don't actually want to do that. We're not building it from an image anymore. We're going to actually attach it. So we want to attach this existing disk to this virtual machine. The other thing, you can see our data disk here is fine. It's already created as attached. Data disks by default are just created as an attach operation, but the OS disk, for I guess reasons that make sense for when you're replicating systems, is a from image. So a couple of other things we need to do, because we're going to reuse this OS disk instead of creating a replica of it. We can get rid of the image reference for the operating system, because it's actually going to be within this disk. Azure will basically say you can't both define the image that you want and attach an existing OS disk. It doesn't make sense, because what if this said Windows and this was a Linux disk? So we just basically hide that away. And then if we come down here to OS profile, the same thing here. We can't define what the operating system profile is in this ARM template, because it may differ from what's in that disk we're attaching. So we basically comment them out. Now everything else in here should be good. Everything else in terms of the security profile, any extensions, if I added any extensions here, should be on it. Anything that's within the operating system disk, like the credentials for accessing this, I have this as just a manual logging. If I'd used an SSH key, then this ARM file would include the reference to the SSH key, which would be stored in the key vault. So for the most part, everything is here. So I'll just save that file now, and we'll close out with that. And what we're basically going to do is we're going to deploy that ARM template. It's going to reattach these existing resources, and we'll be good. Okay, now let's just, we won't go for a caveat just yet. Let's go ahead and do that. So if I search for ARM templates, you can see I've got deploy a custom template. I can build my own template, and then I can load a file. So we will just simply browse to that template file. It's all loaded up there. Hit save. Same subscription, same resource group. It's picked up the region. It's picked up the machine name. So these are the parameters now. There's the default value for that OS disk and the data disk and the network interface. Okay, I'm going to review and create. And we're going to give it a moment. Okay, I paused that for a minute there while it finished creating the resource. So now if we go back, let's go back to our resource group. We can see here is our virtual machine. If we click into that, now it takes a little bit of time for the agent to come back up, once I've rebuilt that machine, but that message will clear eventually. Let's go back and look at the disks. There's our OS disk connected. There's our data disk. If we look at the networking, we are connected to the same network interface, and our public IP is linked to that. The reason we didn't see the public IP referenced in the ARM template is the public IP is linked to the network interface. So that was never deleted. So that relationship never changed. Let's go back to the overview. So now if I copy that public IP address, let's get a command window open. This was the user account I had previously created. It's regenerated the fingerprint key. So let me just go ahead and clear that. So the way we actually go and do that is we use SSH keygen -r, which is for remove. And then we're going to basically just get hold of that IP address again, put that in. That's just removing the fingerprint that was used for the last connection, because that will have changed. So now we should be able to connect. Yes, we'll accept that. Okay. And my password works. So just the password working is proof that, what was in the OS disk has been carried across. So even though that worked, we are still in Availability Zone 1. I intentionally left that. I wanted to repeat this to show how easy it is once you build a bit of confidence in it. So what I'm going to do, I'm going to go ahead and delete this resource again. I'm going to leave all the critical resources behind that I want to preserve. While that's running, we'll come back to our file here, our template file. You can see in here under the resources, we've got the zones. So we're going to go ahead and take out zone 1. Okay. And it might be trial and error. I believe it can just be an empty array, but it might actually to be null. Let's start with an empty array. Okay. And then once this is successfully deleted, let's go back to the resource group, wait for that to disappear. Okay, that's finally disappeared. Then we'll go ahead and we will deploy from ARM template again, build our own template. We'll load the file, take our template file. We can see in here, there's our zone set to blank. And then we'll go ahead and hit save. Everything's filled in as expected, so we'll just review and create. And now we wait. Okay, so that's created. So we'll go back to the resource group. We'll click into our virtual machine. Okay, I actually have to refresh the whole portal there, but now you can see that the Availability Zone ID has disappeared. We're still waiting for the machine agent to fire up again, so we'll see that warning for a moment, but we still got the same public IP address. We still got the same disks attached. We've preserved everything within them. We're connected to the same network device, which has the same NSGs configured on them. Everything looks pretty good. So there's a slight caveat here. in terms of things that may not be persisted. You can't assume everything will be persisted, but most things are. So if we look at things like the access control is not going to be persisted through that ARM template. In most cases, this isn't a problem for a single resource because it's rare, if you're following best practice, that you're going to give role assignments at a specific virtual machine resource. What I tend to do is before I get rid of a particular resource, I will look at the role assignments. I'll change the scope to this resource and just make sure there's no assignments that are assigned directly at the virtual machine. If there are, then make a note of them because you'll need to add them back once you've recreated the virtual machine. Tags are persisted. You'll see them in the ARM template. Networking is typically good. Disk size. So that's just kind of my caveat there is it's still worth checking if there's anything else in here that might give you rise for concern. And most of the time, it's really just making a note of what that configuration is. Look for it in the template first. If it's not in the template, then keep an ID on it. Something around the system assigned identity, I didn't check that. I know I had the managed identity switched on here. Let's have a quick look for that. Identity is system assigned. Has it created a new one? Or is that the same one as I had before? I'm really not sure, so that might be something you'll want to check as well. But yeah, really I wanted to show that in terms of deleting and recreating a resource, in terms of losing the operating system and all the configuration and workload on there, we want to build some confidence that we can safely do that. That was crap. So that kind of wraps it up. There are certain things to watch out for just to make sure that you don't lose anything, but certainly in terms of preserving the operating system disk and the data disk and the network configuration, it's relatively easy to delete and recreate a virtual machine, which in this use case is so we can get rid of that availability zone setting, which we no longer want.